An MRI machine is one of the most complicated and marvelous pieces of engineering. It can give you a detailed 3D image of your body's insides. Our body is mostly made of water, carbohydrates, and proteins, all of which are rich in hydrogen atoms. Each hydrogen nucleus behaves like a tiny spinning magnet, a property called spin. To harness this property, MRI machines use a superconducting magnet chilled with liquid helium, carrying enormous currents with zero resistance. Those circulating currents generate a very strong magnetic field. This powerful field forces all the hydrogen protons to align neatly along the longitudinal axis. Next, another set of coils, the RF coils, deliver a burst of radio waves. This energy knocks the tiny magnets sideways so that they begin wobbling together in sync along the transverse plane. At this moment, detector coils placed near the body pick up the collective wobble as an oscillating signal. But by itself, this signal is just one big noise. To deal with this, these large spiral coils are activated. They create tiny variations in the magnetic field. They make protons in different parts of the body wobble at slightly different phases. This transforms the signal into striped patterns, black and white bands that encode spatial information. After the RF and gradient coils are turned off, the spins gradually lose sync and drift back to their original alignment along the main field. This recovery happens at different speeds in different tissues in the body that make fat, muscle, and fluids distinguishable. Each activation of the system captures one of these striped patterns. By repeating the process many times with different gradient settings and timings, the machine collects a whole library of patterns. Finally, all these patterns are combined mathematically using a Fourier transform, converting them into a sharp, high-contrast image. Repeating this slice by slice builds up a complete 3D scan of your body.